All right, so rational and irrational numbers. First of all, I'm going to talk about what numbers would be considered rational. So the first thing that we said would be considered rational would be the natural numbers. Do you remember what I said the natural numbers were? Like what? 1, 2, 3, 4, 5. Numbers that you learned to count with. Okay? Old joke. Get some new ones. Get some new material. All right, the next type of number that would be considered rational would be considered a whole number. A whole number. Whole numbers include all the natural numbers, but it also includes the 0. Okay? Next, we have the integers. Integers include what type of numbers? Integers include what type of numbers? Negative numbers. So we have those negative numbers, but again, we do not have any fractions, any decimals. It's kind of like a number line, integers. We have some side conversations going on. Next, we said all fractions. All fractions, and I put the word all in caps because I do mean all fractions. So the fraction can be just a normal looking fraction like 1/2. It could be an improper fraction like 5/3. It could be a mixed number like 4 2/3. It could be a negative fraction like -1/4. All of those are fractions. Okay, so if it looks like a fraction, then it is rational. Then we said things that we learned about on Tuesday, which were what was next in your list? Perfect squares. If you have your notes, that should be next in your list. Perfect squares. So on Tuesday, we made a big list of perfect squares, didn't we? And I said I wanted you to be familiar with the first 10 perfect squares. So let's say them. 1, 4, not 2. So we're looking, hold on, time out. We're looking at the number that's inside of the radical sign. All right, so can you do that without looking at your notes, without looking at that reference sheet? All right. All right, so let's close our eyes then and try to do it. So visualize. Josh. What I'm visualizing is, I have my eyes closed. I figured it was you. 1 times 1, 2 times 2, 3 times 3. I'm thinking that in my head, and what comes out of my mouth is going to be whatever the answer to that is, the product. Okay? So let's do it. 1. All right, pretty good. So we got a little uncomfortable there towards the end, but that's pretty good still. All right, so once again, what's inside of that radical sign, that is what's considered the perfect square, okay? Not the whole number equals. And we're going to actually talk more about those perfect squares tomorrow. We're going to use those perfect squares to round or estimate a square root that's not perfect. Okay, and then we started talking about decimals yesterday as far as like what is a rational number. So we talked about 2 different types of decimal numbers. What was one of the types, Keely, of a decimal number that we talked about? Did you pick it up? Okay, so everything's okay now? The packet. Yes, so as long as you're paying attention to me now. All right, so what is one of the types of decimals we talked about? Terminating decimals. What word did we say terminating means? Stops. So we're saying vanilla ice now, I guess. Yeah. Yes. He's almost as old as the Job 21. Almost. So 1.23 would be an example of a terminating decimal because there's nothing after that 3. It stops. Okay, it terminates. And the other type of decimal was called a repeating decimal. Repeating decimal. And we say there's two different ways that you can write repeating decimals. So I could write it 0.222 ... or I could write this. Great, so I gave another example. 0.222 could be what? A line over what? Over the 2, not the 222. 0.2 with a line over it, just like that. Okay. So all of those things are rational. Maybe you like this list a little bit better because it's a little bit more concise because we had already talked about it, so I could go through it faster. So let's talk now, and we did talk about it yesterday, but let's talk about those irrational numbers. The list is much smaller. So irrational numbers don't make a lot of sense. The decimals do not stop or repeat. Okay, so we said non-terminating, but I'm just going to use the word doesn't stop. Okay, decimals that do not stop or repeat. Decimals that don't stop or repeat. They keep going without repeating. For instance, 7.2891 ... You do not know what's coming after that 1. There's no way of knowing what it is because it is irrational. Okay? So it's a decimal that doesn't stop or repeat. It makes it irrational. The most famous of all decimals that don't stop or repeat. It does kind of sound like that. Maybe we could make a song for this number. It sounds like a spin-off of Rudolph. It is pi. Okay? That is the pi symbol. Now, I don't know yesterday if we had time to talk about pi. I don't think we did. So let's make sure let's add this into your notes. Pi. If you need to see how I made that symbol again, I did kind of like this, and then I did 2 lines straight down. Okay? I did that, and then that. That's the pi symbol. Depending on the different font that is used, you know what I mean by font, right? Like typing. Okay? Sometimes the font makes it look like this. So just be aware that different fonts might look different if it's a typed version of pi. Okay, I'm just telling you. So how do you spell? We have lots of talking over in that corner. She must have dropped her gum again. That must have been it. How do you spell this pi? P-I. P-I. It's not P-I-E, like the kind that we all like. It is P-I. Now, most of us that have used this kind of pi before, when we use it, we use the number 3.14. The 3.14 is just an abbreviation. It's just an estimation of pi. Pi keeps on going. 3.14159, I don't remember. There are some people that have memorized like hundreds of digits after the decimal. I don't know why. They have like competitions and stuff. Who knows why? They have a lot of time on their hands. I don't. So you don't need to know all the digits of pi by any means. There was a girl I had a few years ago that was like the passcode on her phone was like the first 25 digits of pi. She had to do that every time she unlocked her phone. She was silly. She was like kind of like an airhead too. Like she was smart, but like an airhead, you know what I mean? You know how people can be like that? Like she acted like she was dumb, but she really wasn't dumb. You don't know her. No. Her name was Bianca. Bianca, not Beyonce. I didn't have her. I'm not quite that old. Not quite. All right, so anyway, so decimals that don't stop or repeat are irrational, and the other type would be non-perfect squares. Non-perfect squares. And we're going to talk about those tomorrow in detail about how to estimate them. But what I mean by those is like the square root of 6, the square root of 21, the square root, see I used 21 there, the square root of 80. There's no way to know what these are without using a calculator, which we're not going to be allowed to use in the first quarter. You're not allowed to use it on the final exam, so I'm not going to have you use it in class and then be like, oh, can't use it on the test, because that wouldn't be fair, right? Final exam is a test. So, CQA, final exam. So you can't use it on the CQA, so we're not going to use it in class now. So anyway, the only way to know what these would equal would be to use a calculator or to estimate the value. And we're going to learn how to estimate the value of these tomorrow. Okay, so what we're going to do now is we are going to look at the assignment. The back side of your assignment is not really an assignment. It's just a little bit of practice. Give me a time check here. What time we get out here? 1:20, and it's 1:05. Do we want to practice some, or do we want to do the assignment? I knew you were going to say that. No, we're not doing the